Welcome back. It's time to start Unit 4, and this unit still takes content from Chapter 3 from your textbook, looking at situational stuff from sections 3.4 and 3.5. We'll talk about multiplying whole numbers, and we'll talk about dividing whole numbers. With no further ado, let's fire up a PowerPoint. All right. Let's go from current slide. All right, well, I'm not going to get to slideshow. There we go. Slideshow. There we go. Okay. So as previously mentioned, content from 3.4 and 3.5, looking at multiplying and dividing. Again, the focus for us as we start the material from this unit is to realize that rather than just launch into the algorithm that shows kids how to multiply or how to divide, and some of you may remember that was pretty painful, there are processes whereby we can use some kind of a hands-on kind of manipulative to help them out. So that's what we're going to look at. There we go. What's in store? 3.4, 3.5. 3.4 is multiply, 3.5 is divide. Objectives, again, I won't read them to you because as a kid, that used to bother me. So I'll let you read them. A lot going on. In the divide section, we will kick around some exponent stuffs. For some of you, that might be a flashback from algebra that may not be too happy, but we'll do okay. All right, section 3.4, multiplying whole numbers. We will look at models. We found that the models were useful for us when we talked about adding and subtracting. So we'll find model opportunities for us as we talk about multiplying. Probably a little harder for divide, but we'll sneak something in there that hopefully will make sense for you. Models for multiplying, we can do repeated addition, or we can use arrays and area models. When you first teach kids multiplication facts, you see them doing repeated additions. If you say, Timmy, what's 4 times 7? You can see Timmy mentally going 7 plus 7 plus another. And rather than learn the multiplication fact response, they actually tend to approach it as a repeated addition. Now, from my own personal opinion, this Cartesian product thing is a little bit of a reach, but I'll show it to you. We'll talk about it. I don't know that it's the best way to approach multiplication, but certainly it's a model we could use. Here's repeated addition. The challenge is to figure out what 4 times 3 is. And you can just see Timmy going 3 plus 3, that's 6, plus another 3, that's 9, it's 12. So again, it works. I don't know that it would be as much fun if you asked the kid for 47 times 15. That'd be a little more tedious to do. But you can see it as a bunch of adds replicating the notion of multiplying. More models, you can see 5 times 4 on the top guy. Don't get confused. Then somehow the overlays of 10 showed up to show you what 10 would be. I'm not sure if that was helpful or less helpful, but that's 20 coming out as 5 times 4, equivalent to 2 times 10. The bottom guy, you and I were big on the arrow method, on the number line method for additions. So that's repeated addition down there, and that would replicate 4 plus 4 plus 4 plus 4 plus 4. You guessed it, 5 times 4. So if you are asking me to multiply some number times a, it simply tells me how many of those a's are going to be added. In this case, that would be n of those terms. Here are some other models for you to consider. I like the area one. I'm not as big an array guy, but I do like the area one. That's an area of 20, which is exactly the answer of 4 times 5. So we will see some stuff with area models as we work through our way in the PowerPoint for section 3.4. Here we go. It's time for Cartesian product. Remember, I think this is a bit of a stretch. So you're going to take 2 classes. You can take world history or ancient history. I'm out on both of those. And then you can also take a language. You can take Latin, or you can take French, or you can take German. I think I might have to sit out this entire semester. All right. So if you want to look at all of the possible schedules that you could create, you could say, well, my history class could be world history, or it could be ancient history. My language could be Latin or French or German, and you could certainly bust out the picture there where you're building schedules, and you could have one of 2 histories, and for each of those you'd have one of the 3 languages, and that is, you guessed it, a Cartesian product model. So you've created ordered pairs, if you will, wherein your first entry is the history course, and your second entry is the language that you've chosen to take. And you can see that if we counted them, there would in fact be 6 possible schedules. So whether you realized it or not, we just looked at a model for 2 times 3. I don't know that it's that useful, particularly if the numbers are bigger than 2 and 3. I should think this might be a bit tedious, but it's a perfectly good model for the notion of multiplying. Right? We took H times L. So you might remember the fundamental counting principle. We met it way back when we were looking at information in, I believe it was Unit 2, that if there are 2 ways to pick a history, and for each of those there are 3 ways to pick a foreign language, then there would be 6 ways to accomplish the 2 tasks together. And quite frankly, the tree diagram makes it nice because you can actually see them. And that's how you and I could use Cartesian product modeling as a means for multiplying. The A times B would tell us how many ordered pairs there were in the cross product. And again, A and B do not have to be disjoint here. They were for our example. World language and history would probably not have had classes in common. Um, Again, if you want to impress your friends with your knowledge, when you multiply, we find products. The 2 numbers that are being multiplied together are often called factors. And that, my friends, will wrap down video 1 for Unit 4. We'll be back soon with video 2. See you then.